another video. Yes. All right, so on to something different. Systems and models. Yes, this will be short and sweet. This lesson is pretty cut and dry, but we are talking about systems and models. Yes, not real, but models that represent something else. So we're, how many of you guys have seen Jurassic Park? Yes, what a real lifelike model that looked like. But nonetheless, some of you guys have maybe taken an interest in making some models, model cars, whatever it might be, so you guys might know a little bit about what I'm talking about, because what we're doing is we're trying to take something that's a little bit bigger and scale it down so that we can look at some of the details and actually compare sizes and so forth. So there's a lot of reasons why we use models. We're going to get into that, and it's going to be nice and concise for you guys. So types of systems, though. Let's talk about systems before we go into models. Systems are so important. When we think about, I always like to think about ourselves as our human body. I am fascinated with the human body, okay? We work so amazingly because of all the different systems within us that work together. And some of you guys know the term that if your body is a little out of whack, maybe you have a cold, you're suffering from a disease, you have cancer, you're not in homeostasis, meaning some of your systems are not working properly and therefore things start to malfunction. So systems are really important for lots of different reasons. We have different types of systems. We have a mechanical type system. We have all of these parts that make up kind of a machine or something, okay? It doesn't have to be necessarily a machine, but typically mechanical systems do involve machinery. And the cool thing about this is if you take, say, an engine apart and you have a piece of it just laying next to it, is it going to do anything on its own? No, it's part of a bigger system. So systems work together to actually perform work and do something. You have social systems where maybe you have a family of, say these monkeys, but they're part of a greater community, okay? And you take those monkeys away, and sometimes maybe you take away part of the food chain, which actually that can work into the ecological systems as well. But social systems and ecological, you have groups that make up larger groups, okay? So these systems, if something is taken out, then it's kind of like there's a missing link, okay, in a chain, and things can start to fall apart. So systems really need to be in place and working properly. And then the biological type systems are kind of what I described before, whether it's in humans or animals. We have systems that work together to make our bodies work the way they do, okay? And our bodies are very efficient, and if some system is not working to its capacity, then things start to go downhill, all right? And ecological, again, if you take a little part of that system out of an ecological system, you might be removing something that's very important from the food chain, and then it disrupts all sorts of things. So systems are really important. You got to have those, got to have them working properly, and they kind of come into all facets of science. So now on to models. Now I'm not going to go into too much depth because your lesson really does describe systems pretty well, okay? So you'll see some examples. Models are great because models help us study some of these things in science that we have to scale down to see, or sometimes we have to scale up. So a model can be blowing something up that's really small so that you can see some of the details, or a model can be scaling something down so that you can kind of get the big picture. So look at this really cool model I found. I found this picture on Google Images, of course. And I thought it was a pretty cool scale model that basically, and I don't even know what city this is, but you take this huge city and you scale it down and you can see the entire thing. Now how often do we get that kind of a view of a city or anything for that matter that's that big? So it's hard to really kind of fathom some of those things. We do it a lot with our solar system, okay? We have to scale our solar system down and kind of the universe because it's so vast, it's so huge, it's hard to comprehend the distances between things and the size. Say the sun, our star, in comparison to our Earth. It's really hard to understand that without actually scaling it down, okay? So there's, again, some more great kind of examples of that in your lesson, so be aware of that and look through those. So why do we use these in science? Well, I kind of touched on that. Think about these questions in your head, since obviously you can't respond to me right now, but what do you think we might use systems and models so often in science? Or why do you think that? And I want you guys to think of some different, things that maybe interest you in science and how you might use models and systems to kind of represent or to help us to understand these things a little bit better. Okay? Again, for me, I love the human body. I'm fascinated with it. That's something that I've always loved to study. And so I think of how the systems work together. But then I also think of all the models that I've used throughout, my college education and so forth, that we are able to use these models to further study some of these systems within science. Okay, so think about that. Think about what interests you and why do you think we might use those systems and models in some of the things that interest you. So the last thing we're going to talk about are inputs, outputs, and feedback. When we talk about systems, there's always inputs, outputs, and feedback. You always have to typically put in something, okay, whether it's energy or sometimes, energy can be in the form of lots of different things, electricity, sunlight, I mean, you name it, different types of inputs. But typically, in order for something to happen, take for instance a car, and I think that's again another example in your lesson. A car, in order for a car to work, which is, a system in itself, it's a mechanical system made up all these different parts that come together and work together and actually drive. But you need an input, right? You put that gas in there and you fill it up. That's your input. Your output is, number one, you go places, so you have that expenditure of energy, but also you have exhaust. So there's some outputs. And then your feedback is, kind of basically what is it, I'm not going to say a car is telling you anything, but there are different ways of these systems giving feedback where it's telling you, maybe your little gauges are saying, hey, you're not working so well, check engine light goes on. Okay, that can be some feedback. Maybe, a part is malfunctioning. So there's many different ways to give feedback from a system. But all systems have these things in order to kind of keep them working the way they should. So, I want you guys to go over that in your lesson as well. Again, it gives some good examples and some good definitions. So, like I said, short and sweet, but systems and models are not terribly difficult to understand, but you guys get a chance to make your own model. So think of something that maybe you want to scale up or scale down, something that interests you, and then you'll understand how important models are and how fun actually they are to study and to even build. Okay? So there you have it for this week. We'll see you next week.